Hello, everybody. I hope you're having a good day. Like I said, Monday, Tuesday, and Wednesday, we will do some AP exam review, and we're only going to do 5 questions a day. And then as we get closer, we'll do more questions, kind of go over the curriculum that we're going over now in chapter 9, maybe get into even chapter 10. And if we see some of these questions on the exam before we even go over, those chapters. We'll just hit them as we go. But for the most part, hopefully, we've hit a lot that's going to be covered on the exam. Okay. All right. So, what I would suggest is before I go through number one, number two, or whatever, uh, pause the video, see if you can answer the question on your own. Check your answer with me and just see how well you did. How much have you soaked in a little bit this year? Again, GPA, I just don't really care about, with all the technology and the things that students are able to do. The real knowledge comes when you actually take these SATs, when you actually take these AP exams. How much did you actually soak in, right? So do really well on these, and let's get started. Okay, number one, it looks like we got a two-way table here that's multiple choice. If you want to read the question, totally fine. But these are pretty straightforward. 1 through 5, I think, is really straightforward. Hopefully, you can see my calculator out here to the left. If you can't, it didn't work last time. We'll just try to get by with it. Okay, a large high school survey their students during lunch to determine whether they bring a lunch or buy the school lunch. Seniors were excluded from the survey. The responses of the 400 students, that's important, are summarized on the table. So a pretty good two-way table here. The question is, what proportion, what ratio, what A over B percent, proportion, decimal of the students surveyed are juniors and. That's a huge word right there. And both at the same time. Okay. And this is not probability just yet, but we can just look. First of all, we want to know this. What proportion of the students, not specific students, all the students? So, first of all, my 400 is going to be at the bottom here. Okay. It's going to be in my denominator. The proportion of all the students, something over 400. What? Are juniors? Well, how many juniors do I have? 101. And buy the school lunch. Who all buy? Well, 273. Well, both. What are the juniors that buy the school lunch? Well, let's look. It goes this way and buy the school lunch this way. Where do they meet at? 49. 49 over 400. That's the proportion of students that are juniors and buy lunch. 49 out of all of the students. This should be letter D. Really easy, like we said, really easy, letter D. Okay, hopefully you got that one right. Again, pause the video before I even do it at all. See how well if you miss it, so what? Find out what you did wrong so that you don't do it wrong again on the exam. Number two, pause the video again. Once again, try to do it on your own. No big deal. Um, let's see. Formula One, I want somewhere to write. We don't always have a place to write, but listen to me as we go. All right. So hopefully you put an answer down, see how well you did. Formula One, it's a popular car racing sport in Europe. Drivers race Formula One cars around the track in a race called the Grand Prix. This histogram displays bar chart that are connected, right? Displays the number of Grand Prix wins on the bottom, right here. Okay, for the top Formula One drivers of all time. For example, how many drivers won 10 to 19? Remember, this bar right here, we don't necessarily count as the first bar. So 20 actually belongs in this one right here. 10 to 9. How many drivers won um, 10 to 19 win. Well, there's about 13 drivers that won. What is this, 1 year? Last year, maybe 10 to 19 wins. 13 of the drivers did that, so on and so forth. The question is, which of the following intervals is the third quarter? And if I could draw this, it would be a little bit better for you. Remember, in given data, we've got our 5-number summary, right? We've got a minimum value, we got a maximum value, we got 25th quartile, right? 25% of our data falls within the this quartile, 50% quartile, which is our median, and 75%, which is our third quartile. Okay. So all we're going to do here is take the frequency, add them all up together, and find out which interval, right, from 10 to 19, or was it 20 to 29, was it 30, involves 75% of my data. So I'm going to grab my calculator right here. Let's just do a little bit of adding. First of all, I got 13. I've got 9. So we got 13 plus 9 plus 2 plus 1 plus another 2 plus 1 plus 1 plus 1. Oh, it looks like I have 30 drivers out here. Well, it did tell me that already, right? So I want to know what is 75% of 30. And I could have just looked right here, right? I didn't have to go to my frequency table. I just want to make sure. Times 30. So where does 22.5 fall? All right. That's the majority of my data. Well, it looks like to me 13 plus another 9 is 22, right? 22.5. Is this 30 and 39? So 22.5 is about right here. So it looks like between interval 30 and 39, 75% of my data is right here. 75% of these drivers are right here. So let's see. Do we got a 30 through? Yeah, we got letter C is our answer. From 30 to 39, that's what the third quartile falls within. There we go. All right. Hopefully you understood that. Good. All right, 5-number summary, guys. We've done these before. Again, hopefully some of you guys have got some of your notes from when we did it back in chapter 1, chapter 2, and chapter 3. Again, a lot of boring stuff, but a lot of people are interested in this a little bit. Am I allowed to do this? Ooh, maybe I can write on here. Ooh, I hope you see that. Oh, Shanae. I like it. Clear it. Clear all my draw. Yeah. Ooh. All right. Here we go. We've got Hunter compared the number of grams of protein in 20 different candy bars, So I've got a sample of 20 candy bars, how many grams of protein are in each? Well, I got a mean of this, I got a median score of this, right? Standard deviation, our give and take, the minimum numbers of protein in some of the candy bars was 1. The maximum was 10, right? My 25% of all of the candy bars is right here. Third quartile is here. Second quartile is here, based on 2 times the standard deviation rule for outliers. What we want to know is, this is a rule to determine, are there any numbers that's unbelievably away from all the other data set that just, hey, there's something up with that number, right? So let's do the 2 times the standard deviation rule. And that's simply this. I'm going to write it, see if I can write it right. The mean plus and minus, oh gosh, plus and minus 2 times the standard deviation. And then are there any data points outside of that? If there are, we've got some outliers, potential, outliers. So let's just do the first one. So in my calculator, I'm going to grab the mean. Again, try to do this on your own. Try to do this on your own. I'm going to do the mean. Clear all my stuff here. Again, you might not be able to see my calculator. Well, what's the mean? I'll say it out to you. You type it in your own calculator. 3.925. And the first one I'm gonna do plus. Okay. Plus, and for me, I have to put it in parentheses. Parentheses. 2 times the standard deviation, 2.408, close parentheses. And all right, I've got a value of 8.7. So my question to you is this. Is there a data point that I know, right? We're not given a dot plot. We're not given any other, information except our 5-number summary right here. Okay. Based on the numbers that they give us, they've only really given us 2 numbers, the maximum and the minimum. Are there any numbers higher than 8.7? Yes, right there. The number 10 is a potential outlier. Now, my question to you is this. Is there any numbers outside of 8.7, that could be below the maximum value? Well, we don't know that. There could be, all right? So let's keep that in mind. First of all, 10 is a maximum value, right? That is an outlier according to 2 times the standard deviation rule, but there could be more in between that if they would give us more data points. We don't know that, but we can't say something like 10 is the only outlier and that's it. Can't say that because there could be some more above 8.7 and below 10, right? All right, so let's do minus now. All right, here's the mean, 3.925 minus 2 times the standard deviation, 2.408. Okay, and let's see. All right, I'm given a negative number. Do we know, based on what they've given us, is there a number below negative 0.8? Well, they've only given us a minimum of 1 and a maximum of 10. Well, even if they gave us more points, I know the smallest thing they gave us is 1 because it's right there. There's nothing below that. So therefore, there are no minimum values that could be outliers. So my answer is going to look something like this. The only outlier I've got is 10, but there could be others. All right. So let's go down. The maximum value of 10 is an outlier. That's true. And no other values could be, that's not true because there could be a value between 8 and 10 that they didn't give us. The only, we've got 20 different candy bars here. The smallest is 1, the maximum was 10. Where's the other ones? They didn't give that to us. They only gave us 5-number summary, a basic summary, right? Let's go on to B. The maximum value of 10 is an outlier. That's true. There could be other outliers. I like this a lot. So B should be an answer. Let's go on to C. The minimum value 1 is an outlier. No, there was the 2 standard deviation rule told me that there is, it's negative 0.891 and there's nothing below that. So 1 can't be an outlier. It's in our realm of things that are not outliers. D, the minimum value 1 is an outlier. There could be other low out. No, if the minimum is 1, and my rule, standard deviation rule 2 times that goes below that. So, it can't be anything else. E, there are no values in the data set that can be considered. Well, that's not true because we just found one. B, number 3, guys, B is our final answer. Very nice. All right. Hopefully again, you're trying these as I go. Okay. because, I don't want you just to sit there and get all the answers off of me. All right, here we go. Let me draw this one. Yeah, let's see if I can annotate here. Again, pause the video, see if you can do it, yourself. Okay. Well, we've got an AP statistics teacher. They want to compare Unit 1 test scores for the people in our class. This year, to the Unit 1 test scores for students last year. Okay. So they did a stem and leaf plot, what they call a back-to-back one. So you can easily read your data. I mean, there's other ways that you can do this. You don't have to put them back to back, but I think it's easy to compare, uh, you know, last year's scores, this year's scores. Uh, displays the scores out of 100. So somebody can make 100. Nobody made 100 on this, it looks like. All right. So this is how you read it. How do you read it? Make sure you put your key in there if we ever have a FRQ. 10/0 means 100, right? Uh, no, that doesn't mean nobody made 100. I was looking at the zero. It looks like uh, this year, one, two, three, four, five people made a 100. Last year, only one person made a. Looks like they're improving in that situation. But let's look here. Which of the following statements best describes the shape? Well, the shape of a distribution could be multiple ways. It can be uniform. It could be, bimodal, right? Unimodal. It can be skewed right, skewed left, um, very balanced, what we call normal, uh, you know, those things. Okay. So, what is this one doing? Well, it looks to me, and we can draw it any which way that we want to. Let's start low to high because usually my bell curves go from, left to right, just a little bit, negative numbers all the way to positive. So it looks like to me last year's 50, you know, 61, gets a little bit higher, gets a little bit higher, and then, real high right here does something, maybe like that, something like that. I don't know. And it doesn't really go back down uh, like this. So if I wanted to, I could actually say, it's bimodal, something like this, something like that. It's going to be really high. Um, to me, this one looks a little bit skewed to the left. All right, let's look at this one. Low, got a lot of scores that are really high right here, and then we're back down, right? So if I looked at this from left to right, this one also looks skewed. Let's look at letter A. The distribution, unit 1, is skewed to the right. I don't see that, right? It's got low scores, high scores, right? Something like this. I don't see it skewed to the right. That skewed to the right looks like, here, here, a lot of data points. That's skewed to the right. This one here looks skewed to the left. Okay. And I know I'm not drawing it right. Uh, distribution of unit 1, both of them look to me skewed left. Skewed to the left while the other one is skewed to the right. That's not right. Both of them to me look skewed to the left. The distribution of unit 1 and last year, this year, both skewed to the right. Looks like D. Distribution of unit 1, test last year and this year, both of them are skewed to the left. I like that one. Distribution of unit 1 skewed to the left. That's true. While the other one is roughly symmetric. Um, no, I would say if I could draw it out, I don't think it's roughly, I still think it's skewed a little bit to it really drops, increases, way increase, and it comes back down just a little bit. I think our answer is D right here. Answer is D. Okay, very good. Very good. Okay. Last one, guys, for today. Last one for today. We got 116 students. We took an average of them. We got a give and take standard deviation. There's a minimum part. There is, remember, we did this with, when we go into our calculator, and it'll give us a 5-number summary. And again, we'll review some of that as they go. This one, very basic. I think I already read the question just now. It's saying, which of the following is the standardized z-score of the maximum height? Remember, z-score is how many steps, how many units. I mean, that's really not technically right when you say units and all that. How many deviations, I guess, is something away from the mean. Usually our bell curve goes out to 3 standard deviations. How much did our data sway from the mean? Something like that. So z-score is all about the score that I want, right? Minus the mean divided by the standard deviation. Well, which of the following, this 8 and 12 and 20, my gosh, that's way away from 3 standard deviations. It looks like to me it's going to be 1.96. So which of the following is the z-score of what? The maximum height. Well, what is the maximum height? There it is. So instead of X, I'm going to put 76. Instead of the mean, I'm going to put the mean. 67 point. I'm writing sloppy. I'm having to trace it with my finger. Divided by what is get away. What are you doing? Okay. What is the standard deviation, the give or take? 4.47. And you guys throw this in your calculator. See if you got it right. Let's look. Oh mercy. Can't do that. Let's look. Should be really, really easy. What I say? 76 minus 67.22. That equals, I don't do division right away because my calculator, I'm afraid it doesn't read order of operations. So take that answer, divided by 4.47. Sorry, 4.47. I got 1.96, and I believe we are correct here. I do want to check this answer though. Let's clear our data. Do want to check the answer. Here's my answer right here. I like it. 1.96. Guys, you are done for today. 1 through 5, make sure you understand it. And that's hopefully a lot of questions on the AP exam. Hopefully it'll be like that, guys, because I think you can really do it, okay? All right, that's it for today. Come back for tomorrow. We'll do 5 more problems. And again, text me on Canvas, text me on not Remind, email me, whatever. Ms. Fisher, can you give me more questions? And I'll do that for you, okay? I'll do as much as I can for you, okay? All right, have a good day. I'll see you tomorrow.